Hello everyone. Today I'll be explaining the concept of hypothesis space and find as algorithm. Two important building blocks in understanding how machines learn from data. I'll keep things simple so that even if you are new to ML, you'll get the idea very clearly. Now, understanding hypothesis space. To start with, let's talk about what a hypothesis actually means in machine learning. A hypothesis is basically a possible explanation or model that tries to describe the pattern in a dataset. Now, the hypothesis space, often written as H, is simply the collection of all possible hypotheses the algorithm can choose from. Think of it like menu of all potential models, and the algorithm must pick the one that explains the data best. Hypothesis selection in supervised learning. In supervised learning, our goal is to select the hypothesis that fits the training data as accurately as possible. We check multiple possibilities, refine them, adjust parameters, and finally choose the one that matches the examples with minimum error. So essentially, supervised learning is like searching through the hypothesis space until we find the best match. Now, introduction of find as algorithm. Find as is a simple concept learning algorithm. Here's the interesting part: it works only with positive examples. It's aimed to find the most specific hypothesis that covers all positive training examples without contradicting any of them. Because of this, it's very fast, easy to apply, especially when the data flow follows clear patterns. Key characteristics and limitations. Findas comes with some assumptions. It assumes the data is deterministic, meaning the same input always gives the same output. It learns purely from positive examples, it completely ignores negative examples. This is both strength and a limitation. It's great for simplified tasks, but not ideal when negative examples provide important information. Now, the steps of the find as algorithm. Here's how the algorithm works step by step. Start with the most specific hypothesis, basically as narrow as possible. For every positive example, compare it with the current hypothesis. Whenever something doesn't match, generalize the attribute by replacing it with a question mark. Ignore negative examples completely. Once all positive examples are processed, the remaining hypothesis is the final answer. Very straightforward, and that's why it's often used to teach the basics of concept learning. Now, here's the dataset we are working with. Some examples are marked positive, meaning they belong to target concept, and some are negative. For this dataset, row 1, 3, and 5 are positive, row 2 and 4 are negative. Finders will only use the positive ones. First step, initial hypothesis. We begin with the most specific hypothesis. HO equals to 5, 5, 5, 5, 5. 5 5's in row. This means we haven't accepted any attribute yet. Now, we look at the first positive example, Japan Honda Blue 1980 economy. So the hypothesis becomes H1. Uh, in that set, it includes the elements of Japan, Honda Blue 1980 and economy. This exactly matches the first positive example. Generalization with next positive example. Now we take a next positive example, Japan Toyota Blue 1990 economy. We compare it with H1 wherever the values differ, we replace that position with question mark. Manufacturer changes from Honda to Toyota becomes question mark. Year changes becomes Toyota. Year changes becomes question mark. Updated hypothesis is H2 equals to Japan question mark blue question mark economy. Now let's go towards the final generalization. Next positive example is Japan Honda White 1980 economy. Comparing it with H2, color differs, it becomes question mark. Year differs, it remains question mark. Manufacturer stays as question mark. Origin and type still match. So final hypothesis becomes H3 equals to Japan question mark economy. So the final hypothesis and interpretation. So the final result of the final find S algorithm is H final equals to Japan question mark economy. Meaning a car will be classified as positive if its origin is Japan, its type is economy, all other attributes can be anything. The algorithm may capture the core pattern no matter the manufacturer, color, or decade as long as the car is from Japan and its economy type is considered positive. So, for to summarize this question, The hypothesis space represents all possible models. Find searches this space and finds the most specific hypothesis consistent with all positive examples. It's simple, it's fast, it's great for understanding how concept learning works. I hope you really enjoyed this video and learned how this whole works, the find algorithm, uh, the positive examples, the negative examples. I hope you like my video. Thanks for watching.